Hello doctors. Physiology of vision is kind of a complex topic. As this picture right in front of you tells, the physiology and the neuroscience behind vision is not something we have completely discovered. It's not something we have completely understood. It's like an iceberg. What we know is little, that is, as the picture clearly says, the iceberg that is seen over the surface of ocean is going to be very little in size, and what's hidden underneath, it's going to be enormous. Similarly, the scientific evidences and the data related to the neuroscience behind processing of vision and the cognitive perception of vision, what we have is quite very less, and what is yet to be discovered is very enormous. So at the outset, I just want you to be clear and aware that there are going to be few grey areas, there are going to be few obscure areas for which we don't have any clear-cut solid explanations and scientific evidences to justify and understand how certain things happen. It's a disadvantage, but still that's how science moves, alright? So people, remember, we don't have answers to certain questions, but yet at this level of your preparations, you got to be familiar, you got to be aware of certain basics and certain fundamentals related to the neuroscience of vision. That's enough. As you advance your understanding and as you keep moving in your career, you could be able to get into the understanding of visual process in a deeper and deeper way. But is it all? No. So like processing of touch, processing of vibrations, pressure, pain, the neural processing of vision is not very clear, but whatever we have so far discovered, that is something we got to know for sure. So with that introduction, people, let me take you to the topics that we are going to learn in visual physiology. We are going to start our discussion with the introduction of visual system. With that, we will be moving on to study the basic anatomy, how eye structures are arranged, what are the functions of each structures, the basic structural orientation. With that, we are going to put our emphasis on retina exclusively, the nature, architecture of retinal cells and how these retinal cells function and how the connections are existing. Once we are clear with these basic topics, we will be then moving on to speak about visual transduction, where we will be looking at the way a single photon of light creates an action potential and how does that action potential is carried to the brain. Alright people, visual transduction. So as I told you at the beginning itself, do we have the exact step after step mechanism of entire visual transduction? No. We know few steps, but in between there are lots of things to be discovered, but the sad reality is we can't go into those details due to the unavailability of scientific evidences and data, but we know the intermediary junctions from where the visual transduction is happening. And then once we know how the photons of lights are getting converted into action potentials in the visual receptors, we will then see how the circuitry functions. What is a receptive field and how the neuronal circuitry functions in transducting a visual stimuli. And we will be finishing our discussion with an overview of color vision. I repeat, it's going to be an overview of color vision because again, we are not completely sure the entire basic physiological processes and the neuroscientific mechanisms in processing color vision. And finally, the pathways, visual pathways, how the impulse that are starting from the retina is carried over to different brain structures, and what happens if these structures gets into some kinds of lesions. So this is the way with which the visual physiology is going to be covered, doctors. Here we will not be covering up oculomotor muscles and the movements of eyeballs, because that is something that will be addressed in the practical discussions. Alright. So when it comes to testing of cranial nerves, oculomotor nerve, trochlear nerve and abducent nerve, in those videos there is going to be a detailed description of eye movements, eyeball movements. So we will not be touching upon those topics, and the reflexes, basic reflexes related to eyeballs, pupils again will not be covered, because this session is going to train you to learn the basics of visual physiology, not the practical dimensions of vision. So reflexes and oculomotor movements will be covered in the practical videos, practical discussion videos. Now this is more for your theoretical understanding and for your theoretical exams, guys. So with this, let's take up the first topic in our discussion, visual system, the introduction, orientation of visual system. People, at the outset, remember, light is nothing but a part of electromagnetic wave spectrum. Electromagnetic waves spans a wide range of spectrum, starting from microwaves all the way to gamma radiations. You have plenty and plenty of different waves: infrared, ultraviolet, X-rays, gamma rays, radiations. You have plenty of waves that are combinedly called as electromagnetic wave spectrum. Light, visible light, is a part of that electromagnetic wave spectrum. As the spectrum spans, we do have waves belonging to the electromagnetic spectrum with different wavelengths. Now light belongs to particular wavelength, and when I say light, I am talking about light that can be seen by human beings. So out of this entire spectrum of wavelengths, what particular wavelength spectrum can be perceived by human beings through human visual system? That is all. As a human being, what is the wavelength that particular individual or life will perceive? If you look at that, electromagnetic spectrum spanning from wavelength of 400 nanometers all the way to 750 nanometers will be perceived as light.